Okay, just to go through the basics of simple harmonic motion here, I'm going to illustrate some of it with an example here. Um, Looking at the forces that are involved here, simple harmonic motion just simply means a repeated motion that goes back and forth, essentially like a pendulum. So if you think of a pendulum here, what will happen? Well, just to break it down here, the pendulum, let's say, starts off at 0. So I'm going to just make my marker here, the pendulum. What's going to happen here is as this thing falls, it's going to accelerate, reaching a maximum speed right about here. At which case, it's going to continue moving, even though there is actually no net force on it at this point. It'll be a force of tension matched by a force of gravity. But over here, it's going to keep moving because of its own inertia and now start slowing down, getting pulled down by gravity and decelerating until eventually it'll basically stop instantaneously and then accelerate back down, have zero acceleration, continue moving, and start slowing down, and then stop, and then keep doing this motion over and over and over again. So the acceleration is definitely not constant. It's the greatest. Okay, it's the greatest right about here. It gets less and less and less to 0, and then gets more and more and more and more and more. Okay, and so the acceleration will just keep going back and forth like that in a pendulum as this thing moves. You can illustrate this with springs and even various types of motions. Anything that's repetitive will do this same action. Looking at some of the other physics behind simple harmonic motion, okay, I'm going to look at a graph. And so what will happen is if we actually charted that pendulum over time, if we looked at its displacement, let's say over time, what will happen is you'll get a graph like this. I'm going to put an X for displacement. So maybe X is wrong. Maybe I'll use a D. So the distance that the pendulum will move will end up being sinusoidal in shape. Now it could be a cosine graph, it could be a sine graph. They look identical except for a phase shift, and one is shifted over. Maybe one will start here at the top as opposed to at the origin here. But essentially what will happen is, just like our pendulum, it moves away, and you can see the acceleration is rather steep, starts slowing down, and eventually reaches 0. Okay, and then it starts accelerating back the other way and eventually reaches 0 again. And it just continues doing that over and over again, is what happens with the acceleration. Now this sine graph, it turns out we can actually, or cosine graph, however you want to look at it, but we can essentially start labeling some things. Notice here, first of all, if I started here, okay, if I started right there, all the way to the next part where it repeats, okay, this time right here, the time that's involved right here, would be actually equal to 1 period. Okay, how many of these are happening per second would be your frequency. Okay, a typical period, if it was a normal graph, would be 2 pi. This isn't always the case, and sometimes it gets shifted, sometimes it gets crunched, sometimes it gets expanded, but typically it's going to be 2 pi in radians. You don't need to know too much about that for the AP, but just understand for basic simple harmonic motion the shape of this, okay, what's happening here. And this will happen for all types of simple harmonic motion.